There we go. Okay. We're talking about perimeter and area of what are called composite figures. Guys, when you look at your notes, what do you think a composite figure is? When you just look at what your notes are talking about, what do you think a composite figure is? Steven? Hey guys, I can't hear him. He's literally in the front row. Thank you.
Irregular shape.
A what?
Irregular shape.
Steven says an irregular shape. Who can expand on that? It's a great idea. That's good. Who can expand on that? It's an irregular shape. A shape that might have two other shapes? Yeah. Caroline?
It's not closed, or it doesn't have even sides.
Doesn't have an even number of sides. It will be closed for us, but it doesn't have an even number of sides. Composite shape is a shape, it's a combination of those. So Luke said multiple shapes, Stephen said irregular. It's because it's an irregular shape made up of other shapes. That's what a composite shape is. So a composite shape is when you put more than one shape together to make a new shape. It's kind of like this classroom, right? This classroom could be, a rectangle and some triangles.
Looks like a rhombus.
It's actually a hexagon. There are 6 sides in my classroom. 6 sides in my classroom. All right, so here's what we need. We need to find the perimeter and the area of this shape. Perimeter on this one will be very straightforward. So we've got 3 sample problems that we're going to do. Let's do perimeter first, because it's really easy. If I were you, I would use the space to your right, to the right. All right, so the perimeter of this is just add up all the sides, right? So this is pretty easy. Where should we start? Who wants to start this? Bless you. Yeah, Kobe.
Or let's start with 11 and 7. No, 11 and 13.
Cool, let's start with 11. So 11 plus 13 plus what?
7.
Let's go in order.
9. That's what I meant.
9 plus,
7.
let's go in order.
Oh, 4.
4 plus 7. Now, you don't have to go in order. You don't have to. I just think it's helpful so you don't accidentally forget a number. Count the number of sides you see. How many sides do you see? How many sides? Careful, there aren't 6 sides. There are 5. 11, 13. Got 11, 13, 9, 4, and 7. So perimeter on this one, we just use our calculator, add that up, and we get P equals what? 44 meters. Okay, so perimeter, not too bad on this one, right? You were given all the sides, which is kind of nice. You were given all the side lengths. Pretty straightforward. Area, on the other hand, is a little bit more difficult. Who has an idea for what we could possibly do on this? Saeed?
I'm splitting into 2 shapes.
Good. Which 2 shapes are you thinking?
A triangle and a rectangle.
Yeah, I agree. So I always like to write down a method here. Whenever I have this, I'm going to go add a triangle plus a rectangle. So what we need to do is just split our work. Let's find the area of the triangle first, and let's find the area of the rectangle second. Now, where is that triangle? Where is that rectangle? I would recommend starting with the 4 meter line and just extending it straight down. You good to go on that? So we've got our triangle. Who remembers the area formula for a triangle? A equals base height. And the area formula for a rectangle? Area equals base times height. Good. Now there are going to be different B's and different H's. That's why we're going to do them separately. So let's focus on the triangle first. Do we know the base or height? We don't know either of those. Because what are the 2 perpendicular sides? This and this. Do those have any labels? No. So we're going to have to find out what they are. So, how can we do that? It might help to look at the rectangle. Caroline, what do you think?
11 minus 4.
11 minus 4 gives us 7. So 7 is going to be our height. So why can we do 11 minus 4? It's because this side of the rectangle is 11, and we know that rectangles have opposite sides, parallel, and congruent. So this side of the rectangle is 11, so this side of the rectangle should be 11, because they should be congruent.
Yes.
All right? Now, the same thing is true with the other side of that rectangle. Anna, what can we do?
13 minus 7.
Good, because this side right here is 7, because the top of the rectangle is 7, which means this piece would be 13 minus 7, giving us 6. And now we can plug that into our calculator. 1/2 of 6, actually we don't need to. 1/2 of 6 is 3 times 7 is. Oh, so we're done. That's the answer to our problem, right? No, why not?
You can divide by half.
I already did that.
Oh.
1/2 of 6 is 3. 3 times 7 is. So we're done. We have to add it to the rectangle. Why did I have you guys write that method down? Because I want you to remember that you have to find the whole area. So let's find the area of the rectangle. Different B and different H though, right?
Yep.
That's why we keep it separate. What's the B and what's the H here? 7 and 11. And that is 77 meters squared. The final step is to do what? Add them. Yep. Yes.
Oh, it's for the area, okay. So
Yep.
we're doing perimeter, so it's like they're doing.
So the reason why I had us do perimeter first is because that one on this particular shape is a lot easier. So it's fast. So we add them and we get 21 plus 77, which equals 98 meters squared. So our two answers for perimeter and area are 44 meters and 98 meters squared. Notice the difference in the units. Do you see the difference in the units? Do you see the difference in the units? Okay, good. Just meters, meters squared, because that's area and this is a length. Questions on that one? Cool, let's get one with circles. Okay, so you guys might be thinking, find the perimeter first. Okay, let's do that. The perimeter on this one is going to be a little bit trickier than the last time. It is not 12 plus a bunch of 3s. What do we have to find the perimeter?
So first we have to find, let's say, the other side of the other 3, like on the end rectangles.
Yep.
So if you get 3 on that side.
Good, so Kobe was saying we need to make sure that with the rectangle that we have in the middle, that the opposite sides are congruent. Keep going.
And then on the bottom, you see we have 12 feet, but then you have like the little 2 parts that I say 3 feet. So you do 6, because you add them both together, minus 12, and you get 6 feet. That's the middle part.
The middle part, what would we call that if we're talking about our circles? What length is that called? Nope. The diameter. So this is 6, and that would be 6. Unfortunately for us, that is not part of the perimeter, right? So the perimeter is all those 3s, right? Right, so we got P equals 3 plus 3 plus 3. That's on the left-hand side. Then on the right-hand side, plus 3 plus 3 plus 3. Plus what else? Well, what about the bump on the top? What's that curved part? What is that? It's not the circumference, it's a semicircle. So how do we find the circumference of a side? Hey, remember that question I had you answer? How do we find the circumference of this bump, of the top bump? How do we find the distance around that top bump?
C equals 2 times pi times radius.
So 2 pi r?
Yeah.
That's the circumference of a whole circle. Do we want to find the circumference of a whole circle?
And this will be a half.
So this is half the circumference, right? But wait, Saeed.
There's 2 half circles, so you would want to find the circumference of a whole circle.
Exactly. So when Saeed said find 2 pi r, what I really was looking for was find the circumference of the whole circle. Saeed, can you say one more time why we would find the circumference of an entire circle?
Because there's 2 halves.
Because there's 2 halves. The top half and the bottom half. Yeah? 2 halves equals 1 whole. So 3 plus 3 plus 3 plus 3 plus 3 plus 3. What are all those 3's add up to equal? What is it? 18. Plus what? Well, Saeed said 2 halves gives us 1 whole, so we're not going to use 2 pi r though. Why would we not use 2 pi r? We know the diameter. It's a lot faster, right? We know the diameter, so we can use pi d. Okay? So it's pi times 6. So what is pi times 6? Should be pretty close to 18 something.
18.84.
18 plus 18.84. So our perimeter is 36. Plus plus, or not 36 plus, excuse me, 36.84 feet. It's a 409, sorry about that. So the idea behind this is we had to interpret what we were looking at. Why did we, remember yesterday when we had to find the perimeter of a semicircle? We had to get the curved part and the flat part. Why on this problem do we not need to find the flat part? Why is that not part of our perimeter?
It's in the inside.
It's on the inside. The flat part isn't it's not the perimeter. The perimeter is the distance around the shape. So if we were to trace this shape, right? Let's just think about this. We found out what half the circumference would be 3 pi, right? So we would go 3 plus 3 plus 3 plus half the circumference plus 3 plus 3 plus 3 plus half the circumference. That's in essence what we just did, right? I did all the 3's plus 2 halves. So 18 plus 6 pi. Where did the 6 come from? Yep, this is pi d. Right, that's where that came from. Now, let's find the area. Hey guys, I'm going to let you know, this is a tricky problem. I'm not going to lie. These are tricky problems. I'm only giving you a small number of them. There are not that many that we're going to do, okay? So let's find the area. How are we going to find the area of this? We need to split it up, just like we did this problem, or we had a method, add the triangle plus the rectangle. What are we going to have here? What are we going to add? What's our method? A rectangle, excuse me. Rectangle plus what? A whole circle or a half circle?
Whole.
A whole circle. Why?
Because you add them two together. 2
halves, right? So I'm going to do it like this. It's 2 halves. 2 halves of that circle. So let's now get those area formulas. Remember to split your work up, right? I may not have given you enough space, did I? I'll give you more next time, I apologize. You can also use the space at the bottom. We're not going to do the third problem. The third problem is for you to do if you want an extra example. Okay. So the rectangle. What's our area formula? A equals, face on side, your eyes. Can you stop doing that? Thank you. And the circle, what's the area formula for a circle? A equals?
Pi r squared.
Nice, pi r squared. If you didn't remember, just flip back in your notes, 1 page, right? Let's do the rectangle first. I think it's a little bit easier to see. What are the base and height of our rectangle? Where did the 12 come from? Yeah, that's one way to see it. Anna said the 3 plus the 6 plus the 3. That's one way. Outstanding. That's an awesome way to see it. What's the other way? You're given this length from here to there is 12, so that's the other way that you can see it. Okay? 12, and the height is 3. So our area for our rectangle is 36 feet squared. Now let's get our area for our circle. Pi, what's the radius? Careful here. The radius is 3. Why?
Because 36 is that diameter, radius is half the diameter, so diameter.
Did you hear that? That was kind of fast. Can you say it again just a little more slowly?
So the radius is half the diameter when we go to the diameter of 6 divided by 2.
The radius is half the diameter is 6. Therefore the radius would be 3. So I drew that in green. It's a little bit hard to see, but I drew in that radius just so you could see it. So we get 9 pi, which is approximately, be pretty close to 27-ish, a little bit more than 27. How do I know that it's really close to 27? Like, how did I just know that? Because 9 times 3 is 27, and pi is pretty close to 3. So it'd be 27 what, or 28.26 feet squared. So our final area is 36 plus 28.26, which is,
64.26.
thanks, I couldn't do that one in my head. 64 point what? 26 feet squared. So you can see the amount of space these problems will need. Okay, probably actually a little bit more than what I gave you. So I apologize for that. Now, on these problems, I wrote down a lot more for the perimeter than you probably would have written down, because these are notes. I wrote down like the entire strategy. And then I wrote down every step. If it were me doing this, I probably would have just gone straight to 18. 18 plus, and then I would have figured out what do I need. The key is making sure you write down what you're looking at, the pieces. Try to figure out the pieces. One of the big pieces that we often forget is how to find the curved piece of a semicircle. Remember, the curved piece of a semicircle is half the circumference. There will be some problems on your work from home, on your homework, where you're given half the circumference, and you'll actually have to find half the circumference. Okay, so make sure you reference the book if you need, okay? Or reference your notes.